Okay, I think we're ready to go. Yeah, the most unattractive talk in the conference when everyone wants to listen about AI and all the new stuff. When I go to conferences, I usually have the same feeling. I want to learn about new stuff, what's happening in the software industry, and then a talk about legacy code is not the most attractive thing to talk about. And there's still coming people in, so maybe we get more room, the room a bit filled. Yeah, first about a sentence about myself. My name is Roland. I'm an independent software developer and consultant, and I help software development teams with their legacy systems and bring their legacy systems into the future. And when I'm not working in projects, I talk about my experience in conference talks like this or give workshop trainings and so, and you can find me on LinkedIn and all the other icons that you can see on the slide. But the topic legacy code, it's still relevant today, and it's even relevant for conferences when you want to learn, when you actually want to learn about new stuff. But on the other hand, who of you has to work on a daily basis with systems that are 5 years or older? Yeah, nearly everyone that comes to this talk is working with legacy code, but on the one hand, you can learn about all the new stuff here in conferences, but on the other hand, in our daily job, we have to deal with these old systems and make the best out of it. Yeah, what is legacy code? I asked ChatGPT to provide some facts about legacy code, and when you ask 5 developers, then you get 5 different answers or 5 different definitions. And yeah, legacy code is the one that's still used in productive systems. So legacy code systems are the one that provide business value. If they didn't provide business value, then we would switch them off and we will forget about the legacy systems. But legacy code is still relevant, it's still in productive use, and so it's still relevant. On the other hand, the test coverage in legacy code is not that big, and most of the time even less. We have documentation, and one aspect is mostly that the experts that built the systems in the early days, they are still unavailable, or they're not longer in the team, maybe not in the company, so all the expert knowledge about the system is gone if it's not documented. And these are some aspects that we have to deal with when we work with these legacy systems. And the first reflex when we see such legacy systems for the first time is that every developer wants to throw them away and want to rewrite them from scratch with the newest and fanciest technologies. And when do we want it? Yeah, every 3 years. So once we have the first rewrite done, then the 3 years are over and we want to rewrite it again because there are new fancy technologies out there, and we are rewriting and rewriting and rewriting, and that's not really effective because but it's hard to say that when we rewrite the system, we make it better than the first version of the system. So it's really time-consuming to do a big bang rewrite, to throw all away and build a new system from scratch, because in the end we will have also deadlines that we will have to meet, and the time pressure, we will skip the first thing we will skip is documentation. The next thing we will skip is testing. So in the end, we will rewrite a legacy system with a new legacy system. So what to improve instead? We can't do a big bang rewrite every time, every 3 years or every month. So what should we improve instead? I would say let's improve this part of the system, these components that we are still working on, where we need to add new features, where we have to fix bugs and see that we add documentation, that we add tests to make the code more understandable. The next question is, should we rewrite the code or should we refactor it step by step? And I would say we only should rewrite the code, so throw it away and rewrite it only if we have enough test coverage to see if the new system works the same way the old system did. And that has, there's a simple reason behind that, because there are so many behaviors in little components, and this behavior needs to be there even after we have rewritten the system. And sometimes we can't really figure out, is something a feature, is something expected behavior, or is it a bug? And maybe from our point of view, something is a bug, but the client or consumer of our API will say, no, no, that's the expected feature, and I want the system to behave exactly like this. So the same behavior needs to be there after we have rewritten the system or after we refactored the system. And the origin of this talk was that a colleague asked me the question, how is it possible to increase the test coverage in legacy systems? How is it possible that even for the worst spaghetti code, how can we add more automated unit tests? And the answer to that is rather easy, because we need to identify the behavior of the system or of the component and then add tests that reflect this behavior. Okay, and yeah, how to understand the current behavior of a component, of a module, of a unit, and where should we start? Yeah, when we want to improve a component, mostly it's because we are still, or we have to work on that because we want to add a new feature, or we want to fix a bug, or we have to fix a bug. And the first thing we will see is the issue or the ticket that we have to work on. And here you see 2 developers, and the one is complaining about the not so explicit bug report. It says it's not working, bitch, and the other developer should write should more explain the bug reports and what is the bad language. And when they try to reproduce the issue, and you get the same error message, it's not working, bitch. But that's a good starting point to explore our code base, because we have an error message and we can start with Control F, search where the error message is happening, and from there we can work our way to some point where we can execute this little module or this little unit within our IDE. And what really helps to explore the code is a feature that most IDEs usually have today. It's the call hierarchy, so that I can explore where is a code unit used, so which method called which method, and that I can find out maybe there is a REST API that I can explore, or maybe there's a unit test, or some point where I can start write a main method so that I can execute the code in my IDE. And once I'm able to execute the code in the IDE, then I use my favorite tool, which is the debugger, so that I can explore step by step what's happening inside the code base to mentally process the logic in each code unit in each step and so that I can see the bug in slow motion. And what helps me understanding the code base, I want to show you a small example. Therefore, I have to switch to the IDE. And I have a little example project, which is the gilded rose refactoring cutter. Basically, the idea is we have a small legacy system, and we should add a new functionality. The gilded rose, the domain logic is we have items, or we sell items, and each item has a name, and has a sell-in date, and has a quality. And after every day, the quality is decreased by 1 point, and the sell-in date is decreased by 1 point. But there are special items like the cheese, where the older the cheese gets, the more quality it has, or backstage passes to a concert, which lose completely the quality once the concert has passed, and so on and so on. And the task is to implement conjured items, which means the quality changes twice as fast as for normal items. And let's scroll here through this business logic, the update quality method. Yeah, you can see, like in usual legacy code, it's not just 5 lines of code, it's several pages long. Okay, let's find a place where we can execute this code method. Maybe we have tests. Yeah, we have a main method, not that fancy, but we have actually a unit test, at least a test method, but okay, the same as in usual legacy projects, we have a fix me. So no unit tests, no documentation. So we have to figure out how this code works and how to add a new feature in here. The first thing I noticed is all these noisy array accesses. So every time the access to the array and IntelliJ highlights the for loop, maybe I can refactor that to a for each loop. Ah, okay. That sounds pretty nice. What else does IntelliJ highlight? This one is great here. Quality equals quality minus quality. And you already had the first or second coffee in the break and mentally processed that this equals 0. So we can simplify that. Other things I noticed is all these lines, quality equals quality minus 1, or quality equals quality plus 1. And for me, it's easier to read if that's quality minus minus or quality plus plus. So yeah, we can simplify the code here, plus plus, and so on. The next thing I notice is we have several if-else blocks, if and else, but the if condition has negations in them. So if the item name equals the brie cheese, if it's not this item, then we have some code to execute. But if that's the brie cheese, we have to go to the else block. So if the condition is true, if the name matches, then we don't go to the if block, but we have to go to the else block. So we have double negation something here. If this is true, then we have to go to the else block, but that's hard to mentally process. So what I do is revert those to get rid of these negations. What else do we have? There are some more here in these. Invert here and invert here. Okay. The next thing I notice is there are empty lines. And this looks like the author of this code built multiple, or had several thoughts. Maybe these are 3 different steps. So the first if block is a step, maybe the second block is a step, and the third block is a step. Like if you have a book page and every new thought is a new paragraph, and after a paragraph you have a blank line, and it looks like the same here, that we have a code block, a blank line, and a new thought in a new code block. And let's extract that into new methods. Let's call it that step 1, step 2, step 3, because I don't know what a good name would be. But now we have split this big update quality method into 3 smaller parts. And it even fits on one screen. So we have a simple if condition here. Let's see what happens if we invert that. If the sell in date is not yet, or if the sell in date is expired, then we have to execute some logic. Maybe we handle the expired item here. Handle expired item. So I try to give this one step a meaningful name, or try to find better names in here. But what I do here is I try to refactor the code, even if I don't understand it, even if we don't even have tests for it, just to work with the code, try to do some refactorings, and most of the time what I did here is using functionalities or features of the IDE to do automated refactoring, so they are less likely to introduce bugs if, for example, if I would move code from here to here, would introduce bugs, but moving around the code with the IDE will maybe not introduce new bugs. And then I would go on, split these big if-else statements into smaller if-else statements, try to extract methods, give these methods a name, maybe introduce new variable names also, extract maybe this one. It's basically based on item names, so maybe introduce switch blocks and so on and so on. But the idea behind this technique, what I showed, is a technique called scratch refactoring, where I start refactoring the code with the goal to understand what happens in the code, to learn about the code base through small experiments, through refactoring, try to find better names, trying to restructure the code. And after I've done that, after I learned something about the code unit, whether it's a small method, about a method or a class or a couple of classes, maybe I have a better knowledge about them in the end, but I'm not sure if I make the code better. So after my refactoring attempts, I will revert everything and have the advantage that I learned about something, about the code, by working with the code, and now I can try to concentrate on the new aspects. And when I do the scratch refactoring or try to understand the code, basically I'll do a code review, something that you would usually do after implementing a feature when reviewing pull requests or so. And what helps me here is the code review parameter. It's basically the idea that we have several aspects in the code review that we should concentrate on, and some parts that we can ignore or don't spend much time with. For example, the code style is not really relevant when we review code or when we review legacy code. Tests and documentation, we already saw that we don't have them in legacy code, but what's really interesting is are the semantics of our API. So what is the interface for our code unit? What are the input parameters, for example? What are we doing in here? What is the logic? And what is the output that comes as return value, for example? Once we understand what's happening inside the code, the next thing I'll usually do is put all the knowledge I gathered into the code base, so documenting the code, something that developers really don't like. Most of you would, or what I usually hear is our code is self-documenting. So who needs documentation if everything is already in the code? We saw that in the update quality method. It's not really self-documenting, but I want to show you two little Java functions that I saw in a project, and they are really self-documenting, right? We have a parse date method that takes a string as an input parameter and returns a Java util date. It was from Java 7 also, or Java 5 when it was originally implemented. And it basically calls the date format method or class from the JDK. It takes a string, returns a date. The name says is parses a date, so everything is documented, right? But what about the input format? Do we have day.month.year, or do we have year-month-day? Or what else could we input here? Or maybe everything is accepted, I don't know. What happens if the input string is a malformed input value? So if we put in garbage like hello world, can we input null? What is this parse exception that's declared there? And what about the thread safety? Everything that's not really documented here in the code. So these are some aspects that I would concentrate on what should also be documented. Another function in the same project I saw was this format currency method. It takes a double as input parameter and returns also a string. And it was a context of a German project, so there's local Germany, so I would expect there's a euro symbol behind the thing, but we really don't know if it's what the decimal separator is, what the thousand separator is. It's not really documented in here. We have to look into the definition of the number format class of the JDK. I saw these both functions or methods when I was in a project which had the goal to upgrade the system from Java 8 to Java 11. And we had unit tests in these projects for these two functions, and after the upgrade, they failed. The first unit test was an unparsable date. So someone put in a date.month.year space hour and minute. And it seems like with Java 8, this was a parsable date, and with Java 11, now it's an unparsable date. And now is the question, was this parse date method a shortcut for the JDK method? So should I change all callers to the new format, or should I change the implementation so that the unit tests are green again? It's not documented, so I will have to explore the code base. And another test failure was this one for the format currency method. 0,00, expected value of 0,00 space euro symbol, but the actual value was 0,00 space euro symbol, which are not the same. Has anyone an idea what's happening in here?
Extra white space.
An extra white space. so maybe a white space behind them or so. Yeah, and it has to do with white spaces because obviously we can't see the difference. The change is with Java 8, there was a normal normal space between the numbers and the symbol. And with Java 11, there is a non-breaking space between those two. It looks the same, but these characters aren't the same. And again, the same question, is it a shortcut for the JDK method, or is it, should I change the implementation of the format currency method? Now you would say, yeah, unit tests are our documentation. Another excuse to not write documentation. When you want to explore a new library or new framework or a new language, who of you reads the tests to understand how to use them or how does it work? Usually it's one or two hands and nobody else would read the unit tests to understand how to use something. So just let us put the documentation right into the code, and it's really simple to write it. What's happening in here is already declared in the code. In the signature, we take in string input and parse it as a date and return the date. So it's pretty easy. No need to add that in the plain text, just add what is the input format. Can we pass null? In which cases will the parse exception happen? Which has the advantage that when the user wants to call the method, he can show the definition or the documentation right where he writes the code. And in the proposal or in the abstract of this talk, or in the title, I said that I will give you 3 principles that you can use already tomorrow to make your legacy code or to bring your legacy code into the future. And the first one I want to give you is, you already know the dry principle, don't repeat yourself. And when it comes to documentation, it's even more that we don't want to repeat what's in the code, just write it in plain text, but I would translate it more into the documentation should reflect the implementation. So everything that's in the implementation should also happen, or should also be present in the documentation. And everything that's in the documentation should also be present in the implementation. So when it says it throws an exception for malformed input or for wrong input format, then I would like to find this in the implementation. And if I saw a throw statement in the implementation, then I want to see in the documentation in which cases will I get an exception here. So it's really summarized in this tweet here. Writing documentation is a kind of a unit test for your software. If you are able to describe how it works, there is a good chance that it behaves like this. And I would add to this, if you are not able to describe how it works, or if you tend to write very long sentences with if this and this and this and this, then there is a chance that you either don't understand the code base or the software, or that it's too complicated. So if you can write precise documentation for it, then there is a good chance that it really behaves like this. Okay, now that we documented the code, let's add some tests. And the first question is, what should I test? And I would say, let's test the documented behavior. So let's see if the documentation that we give our clients or the contract, if that's really working. So let's add a test if the parse state actually parses a date, if we give the specified format, if what happens if we put in null or a different format, so we have 3 tests. When it comes to tests, I sometimes see rather strange patterns. For example, once I was in a project where they have to deal with background jobs, some batch processing, and it was all around jobs. And I found a test class which said, the name was test job, and it had 4 methods. Each test method was around 100 lines long, and the method names were test job 1, test job 2, test job 3, and you guess what the last one was, test job 4. So that's not rather descriptive. So if we see this test failing in a CI environment, I don't know what's wrong. So we can now turn our behavior that we want to test into descriptive test names. For example, when we work with the gilded rose cutter, you will see there is a special item, the sulfurous item, which cannot be celled. So the cell-in does not change, and the quality of this item does not change. And these are 2 aspects, and they make a good test name for that. So the quality of the sulfurous item does not change, and the cell-in date does not change. When it comes to the implementation of the unit test or of a test method, I'd like to keep all the stuff inside the test method that's really relevant for the described test case. For example, when it comes to the quality of the item, we need to first create the item. We have the original quality. We keep this item for several days. And after that, we will assert that the quality did not change. Everything else that's not directly relevant for this test is declared or defined somewhere else. So for example, how to create this item. It's basically a constructor with 3 parameters, but I don't care about the other ones. And to create these gilded rose items and to call the update quality method 4 times in a row or in a for loop, it's not really relevant here for my test. So that's defined somewhere else and it's hidden somewhere else. So when I see the code, I have these 4 lines. Maybe it's even less if we put something together, but I like to keep the relevant stuff inside the test method, and what's not directly relevant, I'll hide somewhere else. Then in legacy code, we have the typical questions. For example, I want to test private methods, and yeah, we have these big classes, 2,000 lines of code, and there is one private method with 50 lines of code, and we want to add unit tests for that. And when we want to test private methods, it's basically a sign that this private method is an independent unit that needs to be extracted somewhere else, documented, and then we can add test for that. Then there are cases where we have to mock everything and verify that some other methods are called. So typically that's methods that don't have some logic in there. So they're just take values from here and put them to here. So nothing really useful. So either delete the complete method or just don't write test for that. And then there are the cases with the hard to mock dependency. For example, the current time database calls or calls to external systems. For example, if we have to do something with the current time, the solution for that is to declare these hard to mock dependencies as parameters. And for example, not invoking local time dot now inside the method, and to hope in the unit test that the unit test method is executed in exactly the same millisecond as the productive code is to just insert the time that we want to format here or to print as external parameter, and then compare them in our unit test method. This is the second principle I want to give you for your daily work, to separate the domain and the logic from the infrastructure. And the reason is pretty easy, because it gets easier to test. So for the domain logic, for the domain knowledge, we can write simple unit tests. And for the infrastructure, to plug our system to other systems, for example, for the REST API, for databases, for UI, for other external systems, we can write integration tests, and there should be no logic in there. In this case, we could, for example, use a clean architecture approach, where the core are our domain classes, our domain objects. Doesn't matter if it's a Spring application, if it's a Java Jakarta application, Jakarta EE or Quarkus, or what else is out there. We have a plain Java domain objects. Around them we have the use cases, or some would call services or something like that. How to interact with these domain objects. The business use cases, we can also test them independently without starting application server or something like that, with plain unit test. And on the outside we have these infrastructure adapters to plug our system to external systems with the REST API to check if requests are getting passed correctly and transformation to JSON is working correctly, or the integration with the database. So, and after we tested our whole code, then my favorite tool is to run the code coverage, because code coverage is too great to find code that we can delete. Either we have red lines, because it's not really good to see, but doesn't matter. Either we have lines that are all covered by unit tests, which should appear green, or we have lines that are still red. So we have found code that is still untested, so we can add tests for them. Or we found dead code that really can't be reached and therefore can be deleted. So, and if we are still doing scratch refactoring, so trying to experiment and learn about the code by refactoring and adding documentation, or provide meaningful names, or add unit tests, the next thing I will do, I throw everything away except for the tests, because these reflect the requirements, or what I think are the requirements for this particular unit. And now that we have the test, it's time for good old TDD. So we have the tests that should reflect our domain logic, or the requirements, or the behavior, and then we can refactor to a design that reflects these defined behavior. And when I thought about how to visualize my approach, I came up with something I called inverted TDD, where I start first to refactor the code, then I write a new test which is hopefully green, or I write a new test that is green. Then, and in the third step, I revert my changes except for the test and see if the test is not red, still green, and that the code coverage is not red. So if there's something red in there, either I changed the code during the refactoring, or I found untested code, and then the circle goes on, or the cycle goes on. I refactor again and write new tests and see which parts are still red, and go on a bit until everything is tested and still green. And you can summarize it like this: for each desired change, make the change easy. For example, if we want to introduce a new feature, but the structure is not right yet, we have to restructure the code to get the new feature in. This may be really hard. And then after we have the a good structure for our, or the final structure for our system, then we can make the easy change. Okay, we have still some minutes left, so we can focus on improving the code. We only added some documentation yet and unit tests for our legacy code base. And when it comes to improving the code, I will again review the code and would still not focus on the code style, but again on the API. So I would like to focus on how to write, or focus on providing a clean, easy API to my clients, to the users of my code unit. And one principle I like here is, it's basically the most basic principle in computer science anyway. It's the IPO principle, where we say, what is the input of our code unit? What are we doing with this code unit? And what is the result? What do we output after that? And for example, we can apply this one here. I saw it a few weeks ago when I was at another conference and I was in the hotel at the breakfast and scrolled through LinkedIn, and I saw this one with the question, what do you want, or what would you like to improve in this code base? It's PHP, but let's see, what is the API of this method? For example, we have a method definition called process, user, and posts, whatever process means in this context. We have a parameter which is called the user ID, okay? But then we have, then we access the session with a session value, whatever that session value is, and we access the post request and extract a post value from that post request. So basically we don't have one input variable, but 3 input variables. And the return value of that one is, we have one case where we return false, so a Boolean. In other cases, we return an array with user data and posts data, and user data is basically all the columns of the users, but we don't know which variables, what type, also it's not really clear in this case. And the post data is basically the same, all columns from the posts table. So this one is rather easy to improve because we can provide a better method name, what's happening inside here, maybe say which are the variables we want to return, extract the session value and post value to the method declaration, and as a last aspect, maybe change the possible SQL injection to a prepared statements or something. And then when we have a easy to understand API where everything is described, then it's easier for our future self in 6 months when we have to dig into the code again, when we start our debugger to understand what's happening inside there and see step by step what's happening in there. Everything that I described and much, much more is also written down in this book, Working Effectively with Legacy Code. If you have to deal with old systems in your daily job, then you should definitely have this book and read this book. And if you want to transform your legacy application on a more higher level, because we only looked into the most easiest part in one code unit, but if you want to take or want to transform your bigger system, then you should look into this YouTube talk, domain-driven transformation. There's also a book. I don't know, it's a German book. I don't know if there's an English version yet, but should be, I think. But what I want to give you are the 3 principles that you can use tomorrow to bring your legacy code into the future. The first is to separate the domain logic and your infrastructure, which simplifies testing. So for the domain logic, we can use plain unit tests, and for the infrastructure, integration tests. And in the infrastructure, there should be no logic in there. The second one, to the other dry principle, you could say, the documentation should reflect the implementation, and also the other way around. What's inside the documentation should be in the implementation, and what's in the implementation is in the documentation. And the most basic principle, you should provide a clean API to say what is your input. So on which state or on which variables do you depend? What is your input? What do you do with this input? What do you process? And what is the output of your code unit? And these are the 3 principles I use in my daily work when I work in legacy code systems, and that I want that I give other developers, or what I try to change in legacy code systems to bring them into the future and to make legacy code more understandable. And what's really interesting in there is, once I've done that, half of the code gets deleted, because it's very easy to delete code once you have understand what's in there and it's tested. And yeah, these are my 3 principles that I want to give you, that you can use tomorrow to make your legacy, to bring your legacy code into the future. And if you have any questions, come up to me and talk to me, and that's it.